they can see things falling into a black hole. But once it gets in the black hole, then nothing comes out of the black hole. So, all right, that's not even true either. But we see what things do come out of black hole. Like there's jets of energy. All right.
I think I can charge my phone in a black hole.
Well, an interesting thing about black holes is we think about black holes as being black because light doesn't escape. Well, light is electromagnetic radiation. So are the radio waves from your cell phone. So as you get closer to the black hole, the radio waves from your cell phone would get sucked into the black hole as well too. So as you're calling 911, all your calls are going into the black hole. Yeah. I mean, there's lots of science fiction where black holes are wormholes that, send you to a different,
Yeah, like little hairs in space-time. Other layers of space-time.
All right, the things we talk about in math class. All right, any questions on the homework?
I did it. Did I have
Questions on the homework?
I did 2 things at homework yesterday.
Nice. Make sure you turn both of them in.
Yeah, I got them both.
Because yesterday I saw your name on yesterday's homework and it never made it into the box. Like I saw you it was on your desk.
Oh, this?
Is that from yesterday?
That's 13.7.
Yes, that was yesterday's. Okay. Because I was like, why didn't Ethan turn his homework? I saw it on his desk.
I didn't finish it.
Oh, okay.
Like,
Make sure to turn it.
I wrote down number 18 and then I just did it.
All right. Eyeballs up here. Any questions?
That was a joke.
Any questions on last night's homework? Last night homework was I claimed it was easy after you saw what was going on. So today would be the hard one. Okay, so the basic idea, Danny, is this. Give me a shape.
number 1?
Give me a shape.
Square.
We take a square, we put it on the coordinate plane, and we tell you the coordinates of the vertices of the square. So how would you like to place the square on the coordinate plane?
On the right.
Okay, so you want from here over? Okay, so we're going to make our square appear like this. We get 4 vertices, A, B, C, D. Where is A? So what are its coordinates? X comma Y. Where is point A? It's on the origin, so it's at. So where is point A? Its coordinates. What's its X and its Y value? 0, 0. Okay. Where is B? So we're going to use a variable for any number. So the X value, though, of point B is, it is 0, but the Y value, we got to assign a variable, pick one. F. If B is F high, so is C. So I already know the, yes, I got it as well too. All right. F is how tall C is. Are you laughing now too? Okay. All right. Never mind. All right.
No. Please continue.
All right. Do you get that part, Danny? Okay. Where's point D? It's over a certain, because it goes X, Y. Got to assign a variable. So it's E, but it's not up and down, so it's E0. If D is across E, well then so is C, and you're done. That was last night's homework. Now, last night's homework, what they really did was they gave you 3. Was it 3? 3 from? They gave you 3, and they took 1 and they put question mark, question mark.
So we had to figure that out.
But we did we did the more challenging one where nothing was listed yesterday. So homework should have been even easier because you already saw the pattern. The only ones that are challenging are the trapezoids and the parallelograms. All the rest of them are pretty simple. Say again? Which weren't even that challenging. Yeah.
I go to the locker, grab my book.
Go ahead.
I'll go.
All right,
So funny. You're doing so funny.
here we go.
So funny.
Number one. Now, actually, there were 2 question marks there for that one. So the top left point was 0, B, and the bottom right was A, 0. Number 2, and it was just the top right. So it was C plus E, D. Number 3, top left, top right. Top left was negative F, 2F, and the top right was F, 2F. Number 4, it was just the top vertex. G plus H divided by 2. It was just 1 question mark, too. Number 5, top right. H plus M, N. Number 6, it was top right again. Apparently, I like top right all the time. N minus P, Q. Number 7, it was just weird numbers. It's no big deal. You had to use the midpoint formula. So it was S over 2 and S root 3 over 2. That was example. Yeah, there were 2 problems there. That was example 7. And then example 8, upper left would have been 3. And then upper right would have been 8, 4. 8, 4. And that's it. That is it. Okay. Matt,
Yes.
grab that basket behind you and collect the homework.
Can I go to the locker and get my?
I said the first time yes, and you kept sitting there.
I don't know. That's sad.
I could play the video again.
No, me. I understand I'm not very. Damn taxes. Give me all your paying taxes.
Intelligence is related to speed of thought.
I don't mean to brag, but I'm a professional tax evader.
I can feel it. Like Cavity's begging me to stop eating.
Pay your taxes.
Cavity's begging me to stop
Pay your taxes. But I ignore the taxes.
Thank you.
The taxes.
And Oreos and your chips.
Why don't you save this for lunch?
He ate everything with my kids. I'll eat.
Why don't you save this?
I'm so.
Okay, calendar. We'll do our 2 chapter reviews. This is the last lesson of chapter 13. There's not many problems, but they're all proofs. The proofs are all going to look like the ones we do. We're going to do 2 proofs in class. The homework is going to look, identical to what we do in class. So you need to write down all the steps on your proofs in class, because tonight for homework, it's going to look exactly the same. Thursday, Friday, we'll do our 2 chapter reviews. We'll take our chapter 13 test on Monday. There are 5 problems tonight. Those 5 problems are all proofs. They will all be done exactly like what we do in class. I'm going to give you the answers to every problem in homework in the 2 proofs that we do.
Oh, that's our homework.
I'm going to give you the answers to all the homework in class.
Hold on a minute. What are we doing? Homework?
He's doing the play thing.
I am perfectly good.
I mean, they're not like persecuting people over it.
Yeah, they've been persecuted. Like next thing, like there's some.
Well, I heard that a couple of 6th graders.
Well, we can do that to one kid before we get in trouble.
Really?
Guys are gonna call them.
Is it Walmart for one thing?
Yes.
So they go by.
Yeah, it's one kid and then they're in trouble.
Chris, he's breaking the dress code. Oh,
No,
well,
that
yesterday
is-
when we were in the students class, like for SA, there's like these 7th graders that were like, okay, so I guess they
It
did
was-
something in the students class.
They
There's
got
like
detention?
4 kids.
Yeah.
It wasn't even detention. Like she made a joke out of it, like in front of the entire class.
Hmm.
It was. the
Was it a good
funniest
joke?
thing. No, she was
She was
like,
getting onto them. 'cause they're
yeah,
being
but she was like, do you like me? Yes or no? And it took him a couple seconds to answer it.
She's
you're-
like, be honest. And they said, no, we don't.
Oh, good for them.
And then she made them like say why they don't like her and why they act out in her class.
Seventh grade, I'll just say, the seventh grade, they're a challenging group. All right, they're more challenging than the other ninth grade.
Oh, don't worry.
Half the ninth graders are well behaved, other half are not. But seventh grade are like they're in a different. They're actually all nice
They're
kids.
not. No, they're
They're not
not.
like-
They're all a bunch of idiots.
Yeah, I agree with that part. But I'm just saying they're very immature. Like usually seventh graders are way more mature.
Yeah.
This year they're all like. If they were sixth graders, we would say, well, there's nothing wrong with them, but they're not. They're seventh graders, so we say you're not acting like seventh graders.
Hugging in the hallway.
Well, it was founded. So.
Yeah, I mean, everyone there is an idiot, but seventh grade, they were
All right.
beyond.
We were arguably stupid.
So I started off by saying that the homework, there's 5 proofs tonight for homework. They don't seem like proofs tonight for homework. It's going to say prove something. Well, if it says prove, that's a proof. They're not like your typical proofs. They're all coordinate proofs, and they're all sometimes going to show you 2 examples, and the 2 examples are exactly like what the homework is. You're already going to know how to do the homework, but you have to write down what we do in class. If you just sit there like some of you typically do, and you don't write down the proof, which is in front of your face right now, we're going to do 2 of them, then you're going to sit in homework like, I don't know what to do. So third and final time. The 2 proofs we're about to do are what's going to show you how to do homework. Here we go. All right. Last class, we took a shape. We placed it on the coordinate plane and come up with the vertices. We're going to use that knowledge to help us do some proofs. Okay. That process. So we do this so that we can do proofs. Right? Why? It just seems weird that we're just writing down the coordinates of vertices. It doesn't seem like it would help us. Well, you're going to see that it helps us do a very challenging proof. Okay. So coordinate proofs. Last night for homework, they already put the shape on the coordinate plane. And I told you for tonight's homework, with the exception of 4 and 5, 4 and 5 are the only 2 of the questions tonight for homework where they placed it already on the coordinate plane. The other 3, you've got to place it on the coordinate plane. But I'm going to show you where it should go. All right. Remember, our goal when we do a coordinate proof is when you place it on the coordinate plane, you want to have the fewest number of variables possible. It makes your life easier. Okay. We use the axes, we use the origin, and most critically, we kind of think about where the proof is going, and we make sure that where we place that thing, the object that we're placed on the coordinate plane, the shape, where we place it, it's going to allow the logic to flow easily. This is the hardest one right here. And I know I say this, it is really challenging. Once you do a bunch of these, maybe you get a kind of a better feel for, if I place it here, and it's usually because it involves zeros, and makes your life easier. All right. I don't think we'll probably get to that last step right there, but certainly the first 2 we can do. All right. So this is not a proof, but I'm going to show you something. Hey, pay attention to this one tonight for homework. You're going to see this again. All right. I have a triangle, right? And I've already placed the triangle on the coordinate plane. And there's 2 blue lines that come from 2 of the vertices. Doesn't really say much about it. What kind of triangle is that? It could be isosceles. How would you know if it was an isosceles?
I don't know. I just threw it out.
It certainly looks like an isosceles. Clearly, it looks like the bottom is way bigger than the 2 sides, so it's not equilateral. Could we prove it's isosceles? How would you prove it's isosceles?
By getting side measurements and base measurements.
Okay. If you did the 2 side measurements and the 2 side measurements were equal, then it would be isosceles. Now, he's saying the bottom one as well too. Well, I can give you the bottom measurement right now. How long is the bottom? It's 8. So if the 2 side measurements are 8, it's equilateral. If the 2 side measurements are not 8, well, it's either scalene or isosceles. If the 2 side measurements, we're talking OP and QP. If those are equal, then it's isosceles. I guess there's a third way. If we could somehow show that angle O and angle Q are equal, it's isosceles as well too. We're not going that route. Okay, we're going to go distances. So to prove that it's isosceles, well, let's use the distance formula. All right, Mac, can you show me how long OP is using the distance formula?
Well, yeah, I just need to know the distance formula.
Okay, so the distance formula, remember, is D equals big long square root symbol. Take the two X values, subtract them, then square it. And then to that, you add the two Y values that have been subtracted and squared.
Okay, so it's going to be 16.
So where is point O?
0, 0.
And this is why it makes our life easy. So it's going to be what?
16, 9.
16 plus 9.
Yeah, 16 plus
Do you see where he's getting that from? That's what
Yes.
happens when you get to higher level math. All of a sudden, you start doing the distance formula in your head. For those of you that can't do that, it's the difference of the two X values. Well, the X value for point O is 0, 0. So it'd be 4 minus 0 squared. That's where he got the 16 from. And the difference of the two Y values squared, that's where he got the 9 from. 9 plus 16 is... Man, you did the hard part
I
already.
know, but this is the hard part.
25.
25.
And what's the square root of 25?
2.
So OP is 5.
Square root, but not add 16.
I don't know. That's weird. Okay. If we can show that QP is also 5, it's isosceles. Okay. Can you do that one? Wes, in your head?
The other one in my head?
Yeah.
Probably not.
Well, here's the pattern, so you can. I'm impressed, Matt. You did almost the whole thing in your head.
Actually, did do that.
You could do 19 plus 6 or
But I didn't
16 plus
write it
9.
down. Good thing that I did it in my head.
Wes?
It would be the same thing, I think.
It would be the same thing. Good job, Wes. It would be 8 minus 4 squared, which is 4 squared is 16, and 0 minus 3, which would be negative 3, but negative 3 squared is 9. It would be the same thing. Very well done. Okay, so is it an isosceles triangle? Tonight for homework, they're going to ask you to prove something. That's how you prove something's an isosceles triangle. Okay, but we got one problem. This triangle is isosceles.
Oh, I got it right. No man.
You did get it right,
No man.
right? Now, look at the blue lines. They must have been there for a reason, right? I'm going to claim that those two blue lines are medians. If they're medians, by the definition, they go from a vertex to a midpoint of one of the sides. Are you with me? Tonight for homework, almost every question is like this. The median questions. Question number 1, question number 2, question number 3, question number 4. Question number 5 is not like that. I'm going to talk about something about the medians, and we're trying to prove that the medians are congruent. Okay, Cadence, you think the two blue lines are congruent? Okay, how can we prove that? We don't have that as a proof yet, but we will after this, by the way. How can we prove that? What is that for?
There's no.
Alright, let's go.
Well, that was a quick class.
Well.
All right, back to this question. How can we prove those two lines are congruent?
You could find the midpoint.
Last night for homework, you placed a shape on the coordinate plane and you weren't told the coordinates. So in order to do that, we would have to find those coordinates. Well, we'd have to find the midpoint. Okay, the values are listed, so we could find the midpoint. Do you remember the midpoint point off the top of your head? Take the two X values, add them together, divide by 2. So which one do you want to do first, OR or QS? So OR, we got a problem. We don't know its value, right? So we got to figure out where is R. Well, that's easy. Here are the two values. I think I figured out S first, but that's okay. All right, let's do S first. I think that's my animation. Okay, where is S? Where's the midpoint? So add the two x values, and then divide by 2. Add the two y values, divide by 2. What? 3/2 or 1.5, right? So she just did that. That's what she just did. Very good. So we got 2 comma 1 point. Like, why did you leave this? You keep telling me to leave things as fractions. You're going to see why here in a second.
In a second, I said let's see what.
Where's R?
In the middle.
Where? What coordinates?
2 and 1.5. That's not our.
Did you not eat breakfast this morning as well?
Oh well, okay. So
No,
X
I
is
had
minus half.
breakfast, that's
X
probably
is
why.
6. Yeah.
He's right, by the way. It's
Oh,
right because it would be 8 plus 4 is 12. That's not 2 though. That's
It's 6.
6. The 1.5 though was right though, because 3 plus 0 divided by 2. So he at least got the 1.5 right. So he ate half a breakfast today. All right, cool. Why do we do that? Because we now need to show the distance formula. Okay, this one's, I'll help you with this one. This one's hard to do in your head because you got to square 1.5. Okay. So OR, the one that you said to do first would be, let's see, we got to take the two x values, subtract them, and then square. Okay, that's easy. That's 36. And then we take our two y values, subtract them. Okay, that one's got to square 1.5. I'll give that one to you. So 1.5 squared is 2.25. Therefore, OR is how long?
Yes.
38.25.
Okay. And you're like, oh, let me grab my no, you don't need to grab your calculator because that's how long it is. It's the square root of 38. That's perfectly fine. Okay. We're going to leave it that way. We're not going to grab our calculators. If we could show that QS is also 38.25, then they are congruent. Okay, so let's do QS. So 2 minus 8 is, squared is, and then it's the same thing. 1.5 minus 0 squared is literally, now I did it backwards, but it's the same thing. Okay, I got 38.25 again, therefore they are congruent. So we just proved that the medians, now what was the logic? I'm going to back up. The logic was if you have an isosceles triangle, I think tonight they even tell you have an isosceles. If you have an isosceles, no, we're not doing any triangles. If you have an isosceles triangle, then to prove that their diagonals, I shouldn't say the diagonal, their medians, there we go, their medians are congruent, and the medians come from the two angles that are congruent. The way that we prove that they are congruent is that we showed that we used the distance formula, right? But we had to have one step in between because we weren't told where the midpoints were. We had to calculate. We calculated that from, well, using the midpoint formula. You got all that? You see the logic? It was using the midpoint formula, then using the distance formula. Okay, we just proved for this isosceles triangle has a vertex of 4, 3, one vertex, so the origin and one vertex is 8, 0, that the diagonals are congruent. Did we prove it for all isosceles triangles? Just that one, okay? So the real proof that you're about to do is going to prove this for all isosceles triangles. Okay, so the answer was yes for this one, right? Great, we proved it for that one, right? But we didn't prove it for all. So now we're going to prove it for all isosceles triangles. So do you think I'm going to change anything for all? Like, would I have to change anything? Think about what we did last night for homework. Would I have to change anything to do this proof? Where it's at. All we got to change is this 4, 3 and this 8, 0 to something and do the proof exactly the same way. So let's do that. Now grab your pencils. Let's really do this. So we're going to do it for all isosceles triangle. We're going to do a coordinate proof. We're going to combine what we did last night for homework, which was place a shape on the coordinate plane, come up with the vertices, and then do the proof exactly the same way. Find the midpoints, and then use the distance formula to show that the diagonals are congruent. Okay, so this is box number 1. Okay. we're going to show for any isosceles triangle that the medians are congruent. The medians are congruent. So there, it looks exactly like the previous one because it's like the previous one, except that we don't know where P is. We don't know where Q is. So last night for homework, how do we figure out where P was? Chris, where's P? So we got to give it coordinates. We could use X and Y. Book chooses, I don't know why, they choose other letters. I'm going to choose other letters as well, too. I'm going to choose A and B. Okay? So, well, O is at 0, 0, and P is at A and B. Where's Q? So isosceles triangle. Chris, where is Q? This is an isosceles triangle. You had this last night for homework, by the way. What do we know about isosceles triangle? That if we cut it right down the middle. You got it. What is it? It's 2A, 0. Why? Only because it's isosceles. Because remember, if we drop a perpendicular from the vertex of an isosceles triangle, cuts the bottom in half. Well, if this is A, then over here would be another, this is A, over here would be another A, we get 2A. So 2A comma 0. Yes? Sure. Okay. Now, what's our goal here in our proof? What are we trying to do? What are we? It's literally there in black and white. So prove that these two blue lines are congruent. What was the next thing we did in the previous proof? Yeah, but what was the first thing we did? Yeah, we're going to show that the distances of the two are equal. What was the first thing we needed? Numbers for what? Which points?
P.
We got it. It's right here. A, B.
Okay.
What was the next thing we did? And it was what Cadence did.
Find the midpoint.
Okay. In other words, find the coordinates of S and R. And if we have S and R, then we can apply the distance formula to OR and QS. Connor, you with me? That would be a yes or no. Okay. It says, prove that the medians are congruent. Those are the blue lines. Well, how do you prove them congruent? Well, you measure them. How do we measure in geometry? We use the distance formula. So I need to find out O to R, what's the distance? D equals the big long square root of x1 minus x2 quantity squared plus quantity y1 or y2 minus y1 quantity squared. Okay. The problem is I don't know where S and R are. So in order to do that, I need coordinates. So we're going to find out the coordinates of S and R. Well, they're called medians. Median means a line that goes from here to the midpoint. We literally have a midpoint formula. So we're going to use this is what Cadence did on the previous one. She used the midpoint formula to find R and to find S. This will not be a very satisfying answer. This will be a very ugly answer because we have nothing but variables here and then a couple zeros sprinkled in. Okay, what do we want to do first, S or R? Let's do S, midpoint formula. What do we do with the midpoint formula? We take what? Two things. We take the X's and we add them and divide by 2. So take the X's and add them and divide by 2. What do you get? We get A over 2. Is everybody with me? What's the Y value? B over 2. Where are we getting that from? We're getting it from here's the midpoint formula. Take the two X values. The two X values are 0 and A. Add them together, divide by 2. Take the two B values. Add them together, divide by 2. So it's not a very pleasant answer, comforting. Hey, I got 3. No, I didn't get 3. I got A over 2, B over 2. That's where S is.
That makes me sad.
Say again?
That makes me sad.
It does, because we're expecting to get a nice friendly, we don't.
No.
And the reason why is because we started with variables. Don't expect a nice friendly answer if you start with variables. Okay, where's R? Same process. Matt, same process. What do we do?
So you would change the coordinates of R first?
That's what we're trying to figure out. It's the same formula, it's the midpoint formula.
So it'd be 0 plus R.
What? we're trying to find the midpoint of, I've lost my pen, of QP. We take the x values and add them together, divide by 2. We take the y values, add them together. That's what I did right here for S.
2a plus a divided by 2.
Which would be
3a,
over,
2.
keep going,
And 0 plus b divided by 2.
which would be,
Over 2.
I'm pulling you, not willingly, but I'm pulling you and you're doing it. You just got to make the effort, right? Yeah, it's not a comforting answer, but that's the answer. You add the two x values divided by 2. Add the 2 y values divided by 2. No one's going to be happy with that answer, but that's what it is. Connor, what was the big picture? What were we trying to do from the very start? You can use any words you want. Say that again. And in everyday speak, that would mean find out if their measurements are equal. So we need to find that these two blue lines, their measurements are equal. Why do we do this big ugly thing and get these horrible answers right here? Because those are the endpoints of the two medians. We didn't know what they were. Now we know what they are. Now we can, oh boy, use the distance formula on very ugly value. Don't panic. This is what higher level math is about. You don't panic because you're expecting this to be 2 or 3, and you can square that and add, subtract it. It's variables. It's no big deal. The process doesn't change just because what we're plugging in are ugly. And it is pretty ugly. Okay.
Yeah.
Distance formula. Slowly. You're supposed to be writing this down. All of this. This is what your homework will look like tonight.
So if we're supposed to be writing down, why isn't there no red square?
What do you mean red square?
Red
Blue
square
means we work together.
The red square means.
Red square is I give you a definition.
Red
You're just
square
writing.
is put it in your lecture.
Isn't that?
Blue square is write it down on the paper.
Blue square is we do a problem together.
I didn't know it was color coded.
Write it down on the paper.
Good. Well, it's 2 weeks before the end of school.
Uh,
I also show you a green square. Green square is you work by yourself.
Really?
That's
We haven't
seriously.
done since like 8th grade.
Well, geometry, there's not much I ever want you to do by yourself. I want to work with you. That's why it's almost all slides are either red or blue.
The OGs know the colors.
Oh, you get to algebra 2 and pre-calculus, you're going to see green squares. All right. Distance formula with these ugly values. Don't panic, just plug them in. Distance formula, pencils, move. D for distance is equal, big long square roots. You're going to need to have a long square root symbol. I got to take the two x values, subtract them, and square. So what are my two x values? Like, which one are we doing first, OR or QS?
S.
Which one?
QS.
QS. Let's do QS. So take the two x values and subtract them. What are the two x values?
0 and 3a.
X values.
A over 2.
So I take A over 2 and I subtract.
Wait, which one are you doing?
She wanted to do QS first.
Oh,
Over 2A.
And then 2A. Oh. Plus, my square root symbol wasn't long enough. Take the y values. Subtract. What are the y values?
B over 2.
B over 2 minus. Okay, that one's easy.
that's disturbing.
Here's the problem. I got fractions. So when you have fractions and you're adding and subtracting, what do you need?
Another fraction.
Come on, work with me.
Just put like a 1.
Put it like
How do we subtract when one of them is a fraction?
Just put a 1 underneath the 2.
Well, and then what?
And then you just subtract.
No,
Oh, heck.
we're back in 4th grade.
common denominator.
Common denominators. You can't add and subtract fractions unless the denominators are the same.
So it's
So what's the common denominator?
2.
So how do we turn this into a 2?
Or a over 2.
Thank you. You at least,
I paid attention.
well, clearly, because you just told me the right answer, but I had to beat you in order for you to tell me, and only one person said the right answer. And then everybody else like, oh, yes.
That's not fair.
All right. What is What is a minus 4a?
-3.
So we get negative 3a over 2 square top and bottom. What do we get? Square top and bottom. What do we get? You said negative 3a over 2 squared. Square it.
-6.
Uh-uh.
Sorry, 6a.
You
Uh-uh.
add it all the
What?
same.
Square, not multiply.
Oh, -9.
Yeah, but a negative times a negative is not a negative.
9A.
9.
And it's not 9a.
6a.
9 is
9a squared over,
2.
no,
Oh, 4.
4.
We got 90 for a dome big.
Negative 3 times negative 3 is 9. A times a is a squared. 2 times 2 is 4. Okay.
B squared over
Plus,
4.
what is it?
B squared over 4.
B squared over 4. Hey, look, guess what we have? So add those two together. What do we get?
10a over 4.
What?
You can't.
You can't add a squared to b squared.
9A squared plus B squared over 4.
Oh my word, I'm gonna throw things.
Over 4. You don't add the denominators.
All right, now I'm gonna make this nice and pretty. So we got as an answer 9, and it's the square root of it, by the way. 9a squared plus b squared all over 4, take the square root. That's not a decidedly nice answer. It's okay. It's just the answer. Don't panic. Remember, our big picture is we're trying to show that blue is equal to blue. We just did QS and we found it's this ugly thing right here. Great. If we find that the other one is this ugly thing, then we're done.
Oh, we have to do it again.
Because we have to, Connor said, got to show that their values are equal. Okay, so now let's do
Well,
OR.
all you have to do is square R.
That was just one
Because
side.
O is.
Okay, so she's thinking outside the box there. She knows that the distance formula takes the x value, subtracts them, and then squares. And she says, well, wait a minute, if the other value is 0, then we're not really subtracting anything. So all we have to do is square those. So what do you get?
9A squared
Plus,
B squared.
and guess what you get?
Same thing.
The same thing. Okay, nice and pretty. This is why you're in high school and not in 7th grade. You 7th graders will not pee their pants or poop their pants. They look at this, right? You're in high school and you're supposedly able to handle this complexity. It's not that complex. It's just weird looking. The actual math behind it, by the way, I teach not 7th graders, but 8th graders, the midpoint and the distance form. You did it in 8th grade. You did this.
I didn't do it.
You didn't do this because we only plugged in real numbers.
I did that.
We didn't plug in variables.
I actually did that when I was supposed to be doing it.
Okay.
I was down.
No way. That's
Okay.
got. That's got.
By the way, Connor, did we prove it? Yes or no? Yes or no? Are these the same? Like literally, does this blue look like this blue? Is there a square root? Yes. Is there a 9a squared? Yes. Is there a plus b squared? Yes. Is there a 4? Yes. It's all the same. I'll just say, whenever you watch the movies or television, and they're like, oh, smart person up doing math, they throw something like this up there, like, whoa, look at all that weird math. It's just simple stuff. It just doesn't look simple.
You mean to tell me that when people are trying to figure out a mathematical equation in a blue, they just throw a triangle in there?
Yeah, and they throw some junk like this, and they're like, well, everyone's impressed. It's like, it's not, once you're in it, you're a sophomore, right? Once you're in it and you see the stuff, by the way, algebra 2, pre-calculus, it all looks like this. If you can stay in the moment, by the way, all we did was 2 midpoint formulas and 2 distance formulas. You can stay in it. Every single person in this class can pass those classes, but you got to be willing to stay in the fight. Like I said, 7th and 8th graders don't do anything like this because it just looks too weird. But it's not that complicated. All right, there was nothing here. By the way, we just proved it. What did we prove?
Something.
Isosceles.
That if you have an isosceles triangle, that the medians are congruent. Cool, we just proved. And by the way, we proved it using this is called a coordinate proof. This just looks like algebra, right? Doesn't seem like we're really doing geometry because there's a whole bunch of calculations. None of the proofs we did up until now, they all had words in it, a little bit of math, but most of them were words. This one had nothing but numbers and calculations, and this is a honest to God proof. Okay. All right, the last one is like your homework for, I think, almost every single one. Make sure you write this one down. I didn't see too many people, Chandler, Mike, write down anything on the previous one.
I wrote down the
All right. So here we go. No lie, this is literally the first one we did was question number 1 and 2. This one is questions 3, 4, and 5. What do we got? We got a triangle. Does it tell us what kind of triangle?
No.
Does it tell us what kind of triangle? It says the segments joining the midpoints. Let me draw that. The segment joining the midpoints of two sides. So I'm going to claim, look up here. I'm going to claim that these are the two midpoints. So the segment joining the midpoints. So this dotted line is parallel to the third side. And it's also equal to, we've proven this before, by the way. And that this is the, it's called the triangle medium theorem. That this segment right here is half of the bottom one. So I got to do two things. What are the two things I got to show? I got to show that this dotted line is parallel to this one. That's this part right here. And then I got to show that this is half of that. I could also show that this is double that. It would be the same thing. Okay. So we got to prove two things. So I'll do the top one for parallel, and I'll do the bottom one for half. Okay. All right. Anybody want to put their triangle any different place? They think it might make it. By the way, we don't know what kind of triangle it is. It could be right, could be a isosceles, could be acute, could be it could be, and this applies to all triangles, whether they're right, isosceles, or acute, equilateral, equiangular, any of those. Okay, so we got to prove two things. We got to prove that the blue line is parallel to what? To the bottom. And then we got to show that MN is half of OQ. All right, cool. How do you show that two things are parallel? Say again? We could do that, couldn't we? I like that. Very good. If we show that this angle is congruent, that's how we proved it in the past, by the way. We show that these two angles are congruent, done. Do we have any angles up here? No. So can't do that. Why is it in this chapter? Guess what we're going to do?
That one parallel.
So what do you know from this chapter about parallel lines from this chapter? Theorem something. What do you know about parallel lines? Why?
Something
They have the same slope.
They have the same slope. Thank you. So if we show that the slope of MN is the same as OQ, then we're done. Oh, by the way, what's the slope of OQ?
0.
Why is it 0? Because it's horizontal. Hey, you are learning something. So we already know that OQ is horizontal. So we already know one. So if we show that the slope of MN is 0, well, how do you calculate slope? With some coordinates and using the, from this chapter, slope formula. What's the slope formula? Y2
minus
Y1 over. Okay. So in order to do that, I need coordinates. I have no coordinates. So we got to make coordinates. What do we know about point M and N from the setup? They're what? What? Read, please. They're midpoints. Okay. So we need coordinates. So let's start with O. Where's O? How about P? We don't know what it is, so we're going to have to go with AB. Where's Q? We don't know what kind of triangle it is this time, so therefore it's C0. You get that? And then point O is 0, 0. Okay? This is going to be just like the previous one. I'm trying to find the slope of MN, so I need, in order to plug it into this formula, I need MNN. So what formula are we going to use? We're going to use the midpoint formula because It says they're in the midpoints. What's the midpoint formula say? What do we do? Add the x's and divide by 2. Add the x's. Let's do m first. What do you get? We get a over 2. Why is she doing that quickly? It's easy, and she has that formula memorized. How about the y value? B over 2. You add the two y values and divide by 2. Are you writing this down? Right? The proofs are this. This is the homework.
It is.
Instead of a triangle, they're going to give you a trapezoid. It's the same thing.
Yeah, rhombuses, parallelograms. Oh,
If you make a median that's parallel to the third side, right?
Yeah.
Okay. So she got the point M, which was A over 2, B over 2. She got it just by plugging it into the midpoint formula. Take the two x values, add them together, divide by 2. Same thing with the y values. We don't get a satisfying answer, but it's still the answer. A over 2, B over 2. How about point N? No, it says add, not subtract. A plus C over 2 and B over 2. Very good. Now you're catching on. You got to stop me if you're lost, and you're supposed to be writing this all down. If you want to write the steps, that's fine as well, too. I'm just saying you should probably write everything down because it's so similar to the homework tonight. All right, not a satisfying answer for N. It's this weird looking thing. It's okay. It's the midpoint. I forgot what we're trying to do. What are we trying to do? I really haven't. That's a teacher thing. Show that they're parallel. So what formula are we going to use? We already know that OP is 0. That's the slope. We're going to use the slope formula, which is this one right here. Take the two y values, subtract them. Take the two y values, subtract them. Remember, we're using this one and this one. Take the two y values, subtract them, and we literally get 0. B over 2 minus B over 2 is 0. Now, I want you to stare at this. Stare at this. Can you see the top? So here's the fraction bar. Can you see the top? Do you agree that we get 0?
Yeah.
Look at the bottom. Don't subtract and tell me, do we get 0 on the bottom? I don't even want to mess with the bottom, but do we get 0? Because remember, if we got 0 on the bottom, we have a problem. So we get something that gives me 0 over, I don't know, something, but it's not 0, which means it's the value. What's 0 divided by anything unless it's 0? We get 0. So I don't need to do this calculation. I just need to see that the numerator was in fact 0, and it is.
So it's all 0.
So we got the blue line, the slope is 0. We got that the bottom OQ is 0. Done. They are parallel. Halfway there. Tonight for homework, this is questions 4 and 5. It says, prove that the median is parallel. You're going to do it exactly like this. You're going to get to this weird looking thing. Don't focus on that. Denominator is ugly. Don't worry about it. Oh, by the way, you do have common denominators here anyway. Who cares what it is? You're just trying to find a value. If the top number is 0, it's 0. Okay. Last thing is we got to show that it's equal to half. Well, how do you show distances? Distance formula. I got everything there. Okay, they're not friendly. I got everything there. I'm just going to use the distance formula. Which one you want to do first, blue or the bottom? The bottom is the easiest. You already told me. How long is it?
Is this the real bottom?
0. Please,
No.
No.
How long is the bottom?
0.
How long is the bottom?
32.
If I go from here to here, it's the x value. It's C. Stop. We got to finish this. It's C. Do you see that? Pun intended. Okay. So we already know that OQ is C. Look at the board. We know that OQ is C. Why? Because it says it right there. It's C long. 0 high, it's C long. Okay. We just need to do MN. Well, it's just the distance formula. So it's the x values subtracted squared plus the y values subtract. Well, the y values are going to give you 0, right? B over 2 minus B over, that's 0. So it's just this mess right here. Hey, look, I got common denominators. That's pretty convenient. What's A plus C minus A? So, and then we got to square it. So we get c squared over 4, and then take the square root. And what do we get?
That.
What's the square root of c squared? What's the square root of 4? Did we prove it or not prove it?
Not really,
Why did we not prove it?
because it's half of C, not
Yeah.
C.
N is half of L cubed.
We just proved it. Get out of here. Seth, you let me down there.
He wasn't.
Yes, that's exactly what was going on. He thought they were supposed to be equal.
I got through all of 2 questions. And it hurts
I'm going to
myself.
guess it's 4 and 5.
No, I did 1 and 2.
You said I got through all but 2 questions.
No, I did all. No, I did 2 questions.
Only 2 questions.
That's next